There's different types of queues, just like there were different types of linked lists. Every single queue, by the way, has two variables. One is F, one is R. Okay, so F means front, R means rear. Okay, just like the linked list had a head and a tail, our queue has a F and a R, front and a rear. Now, in a simple queue, so F is 0 and R is also here 0. Okay, this is because this is the 0th index. Okay, and then this is 1, 2, 3 and 4. So once I insert something, say I insert a 10, okay, then rear is going to be incremented. Okay, you're going to insert where rear is, and then you're going to increment rear. So rear is now here. Okay, then I insert a 5, and then I insert a 6, right? So now once I inserted a 5, R is going to move one more front, and then I insert a 6 and it's going to move one more front, like that. It's going to keep moving. Okay, so that's the simple principle. Once I want to delete from a queue, I have F, which is the front. Okay, then when I want to delete it, I can just increment F to the next. Okay, so now F is here. So this is just the principle, and once this value is no longer going to be looked at. Now assume I want to put an 8. Okay, then R would be here, and then I added an 8, and then I increment R, so R would be now 5. And once R is 5, then I know the array is full, or the queue is full. You cannot add any other items inside of the array or the queue. You would have to delete stuff. Now that's a linear queue. When it comes to other queues, okay, for example, you'd have a priority queue. Okay, and in a priority queue, it's actually quite interesting, is that leave F and R for now. Okay, in a priority queue, if you insert something like 3, okay, then you say I want to insert a 4. A priority queue is also called a heap, by the way. There's two types of heaps. There's a max heap and a min heap. Inside of a min heap, the minimum value would be the first value. Okay, so I can have here 100. Actually 10, let's put 10, let me put 73, let me put a 5, and then a 20. Okay, let me just assume this is our priority queue. In a priority queue, okay, if it's a min heap, then you'll have your minimum value first. If it's a max heap, you'd have your maximum value first, which would be a 73. So put a 73. I mean, if I want to make this a max heap, this is how it's going to look. The maximum value is going to appear first. If it's a min heap, a minimum value is going to appear first. So that's just a priority queue. And if you insert inside of a priority queue, assume that I have a 2. Okay, and this is a min heap. So I've inserted a 2 inside of this min heap. What's going to happen is that this is going to put the 2 there, right? So 2 is going to come over here, and 3 is not going to be there. Okay, so it's going to heapify up. It's a complex algorithm. Heapify up, heapify down, and the place, basically, just for now, to keep it simple, assume that 3's position is going to change, and 3 is either going to be here or 3 is going to be somewhere else inside of the array. But the point is that 2 is going to be the first element inside of the array because it's the minimum one. Same with the max heap. Then we also get another type of queue called a circular queue, and that's just, it's not that difficult. It's just that we have the front and the rear, and initially these two are not 0, these two are -1. Okay, rear and front is -1. Basically they are here, and then once you insert an element inside of the circular queue, say I insert a 2, then both F and R are going to be initially 0. And how does a circular queue differ from other queues? It's just simple principle is that, let me just keep inserting, right? And now R is here. Actually no, R is not there. Assume I never insert a 3. Okay, so now R is here. Now once I do insert a 3, okay, R comes here, and then R has to move on, isn't it? So R is not going to move on here. R is going to go back all the way around, and R is going to be here. So now this is R. Okay, and then once I insert, then we're going to start inserting here. And that's, I mean, if assume that, F has moved on, so F has also moved on. If F hasn't moved on to the other nodes, and then R is also at the same node, then once you try to insert, it's going to say that it's full. Okay, simple principle. F and R wraps around, in a circular queue. Then you get the priority queue and you get the linear queue. Simple. Thanks for watching.